probability, example 31B. You are dealt 5 cards from a standard deck of cards. How many hands contain at most 2 clubs? So at most 2 clubs means that clearly the maximum of clubs you will have is 2. So what would the minimum be? Well, you could have a hand of cards with no clubs in it whatsoever. So write out what this 5-card hand could look like. Include all possibilities using and or when appropriate. All right, so let's look at the 0 for the minimum. So if you have 0 clubs, remember we are dealt 5 cards. So that means if we have 0 clubs, we're going to have 0 clubs and 5, we'll call them others. Or, now we're not going to go straight to the max. We know what the minimum is and what the max is, so there's something in between there, right? You could have 1 club. And if you have 1 club, if there's 5 cards in your hand, that means you're going to have 4 others. Or, if you have the maximum of 2 clubs, it means you're going to have 2 clubs. Again, you have 5 cards in your hand, so 2 clubs and 3 others. Okay, so that's what that would look like, and they want us to calculate the number of ways the given events can occur. So in this scenario, we do not repeat the cards, so it's without repetition. And order doesn't generally matter in your hand. Now, yes, when somebody deals me a hand of cards, I put them in my own particular order, but it doesn't really matter. So no repetition, order doesn't matter. That sounds like a combination. So we have to remember let's talk about what we have as far as the cards. We have 13 clubs. So our 2 categories here are we have clubs and then the other cards. So if we have 13 clubs, that means we also have 39 others. 13 plus 39 gives us the 52 cards that are in a standard deck of cards. So I'm not writing down all the have and need at this point right here. I'm just pointing out what we have, and then up here will show us how many we need. Okay? Alright, so let's continue on. We're going to calculate the number of ways the given events can occur, and